Okay, good evening students. So today we are discuss about Aldol condensation. Okay, what is the Aldol condensation? So Aldol condensation means, okay, so what is the Aldol? Aldol means beta hydroxy carbonyl compounds, beta hydroxy carbonyl compounds are called aldol products. Aldol products. Okay, so for example, CH3 CHOH CH2 and C double bond OH. So this beta hydroxy carbonyl compounds are called aldol products. So here this is the functional group. Functional group adjacent carbon is called alpha carbon. Okay, alpha carbon. The next carbon is beta carbon. So here beta hydroxy group is there. This is the carbonyl functional group. So this compound is called aldol product. Beta hydroxy carbonyl compounds, aldol products. So next here condensation term is there. So what is the condensation? So condensation means addition followed by eliminations. Okay, addition followed by eliminations. So suppose here A X compound is there and a B Y compound is there. So here these two compounds are eliminated as X and Y eliminated as small molecules, and the A, B and addition takes place. That means A, B and X, Y. So here AB, addition followed by elimination is called condensation reaction. So this is a terms of aldol condensation. So now, so which compounds are participating in aldol condensation? So which type of compounds are participating in aldol condensation? So in aldol condensation, alpha hydrogen containing carbonyl compounds are participating in aldol condensation. What is the carbonyl compounds? We know that carbonyl compounds, formaldehyde. Okay. So next here this carbonyl groups. So carbonyl compounds means the compounds which contain C double bond O functional group. So if this C double bond O functional group contain both side hydrogen, that is a formaldehyde. Okay. So this carbonyl compounds, it contains one side alkyl group, another side hydrogen. So this is a aldehyde. Okay, aldehyde. So in case this carbonyl group contain both side alkyl groups, so it is a ketone. Okay, ketones. So here carbonyl compounds are participating in aldol condensation. So which type of compounds, under which type of carbonyl compounds are participating in aldol condensation? Okay, compound should be compound should contains alpha hydrogens. Okay, compound should contains alpha hydrogen. So compound must be contains alpha hydrogen. Okay, alpha hydrogen. Okay, so here this is the carbonyl compound. So because of this is also carbonyl compounds. So this is also carbonyl compound because of and contain C double bond O group. So next I can write one more compound. This is a acetone. So I can write one more compound. Okay, acetophenone. So this is a one more compound. So this is a benzophenone. Okay, benzophenone. So I can write one more compound, propanaldehyde. So I can write one more compound. Two butanone. So I can one more carbonyl compound. So this is the carbonyl compound. So this is a benzaldehyde. Okay, benzaldehyde. This is also okay. Okay, so then in Aldol condensation, so which compounds are participated? The compounds which contains must be sp3 hybridized carbon, and the compounds which contains alpha hydrogens. So that type of compounds are participated in Aldol condensations. So so before the discussion about the Aldol condensations, we know some knowledge about the alpha carbon. So what is the alpha carbon? So alpha carbon, what is the alpha carbon? So alpha carbon means, so the carbon which is present, the carbon which is directly attached to functional group carbon atom. Okay, functional group or system. Okay, or system. Okay, so the carbon which is directly attached to functional group carbon or system. So that is the alpha carbon. So alpha carbon must be sp3 hybridized. Alpha carbon must be sp3 hybridized. Must be sp3 hybridized. Must be sp3 hybridized. Okay, so for example, CH3 C double bond OH. So here which is the functional group? Functional group is aldehyde. So aldehyde is the functional group. So adjacent carbon is alpha carbon. Then hydrogen is alpha hydrogen. Then hydrogens are called alpha hydrogens. So I can write one more example. CH3 double bond CS. This is the acetone. Okay, this is the acetone. So here this is functional group. This is the adjacent carbon alpha. This is also alpha. Alpha is must be sp3 hybridized. This carbon participate in sp3 hybridization. This carbon also participate in sp3 hybridization. Okay, sp3 hybridization. So that's why it is the alpha carbon. Then hydrogens are called alpha hydrogens. Okay, this type of compounds, alpha hydrogen containing carbonyl compounds, are participate in aldol condensation. Okay, aldol condensation. So suppose here this is the compound is there. So double bond is there. So here this is not alpha carbon. This is not participate in aldol condensation because of this carbon are participate in sp2 hybridization. So sp2 hybridization. This type of compound does not participate in aldol condensations. So in our examinations, examiner how to asking the question. So which of the following compounds are participate in aldol condensation? So that means the compounds which contains alpha hydrogen, that compounds are participate in aldol condensation. So I can here this is the participate in aldol condensation. Okay, this is a participate in aldol condensation. This is a functional group. Adjacent carbon is alpha carbon. Alpha carbon must be sp3 hybrid. So that's why this is a participate in aldol condensation. So I can write second example. So see the second example. So here there is no alpha carbon. This is the functional group carbon. There is no adjacent carbons. So that's why there is no alpha carbon. So it is not participate in aldol condensation. So I can one more example. So here this is a acetone. So this is the functional group. This is also alpha carbon. This is also alpha carbon. Alpha carbon must be sp3 hybridized. Okay, alpha carbon must be sp3 hybridized. So that's why it is also participate in aldol condensation. So here this is the functional group. Adjacent carbon is alpha. So here 3 alpha hydrogen is there. That's why this is also participate in aldol condensation. So next here this is a benzophenone. So here there is no alpha carbon. So this is participate in sp2 hybridization. This is also participate in sp2 hybridization. So that's why this is not participate in aldol condensation. So one more example. So this is a functional group. So adjacent carbon is alpha carbon. Here alpha hydrogens is there. That's why this is also participate in aldol condensation. So one more example. So here this is the functional group. This is also alpha carbon. This is also alpha carbon. So that's why these compounds also participate in aldol condensation. So here this is the functional group. This is the alpha carbon. This is the alpha carbon. But here these two places no alpha hydrogens. Okay, no alpha hydrogen. So that's why this compound not participating is aldol condensation. So I can take one more example. Okay, I can take one more example. This is the benzaldehyde. So here this is the functional group adjacent. This is the adjacent carbon. Adjacent carbon must be sp3 hybridized. But this carbon undergoes to sp2 hybridization. That's why this is not participate in aldol condensation. So here this is a functional group adjacent carbon alpha. But this carbon participate in sp2 hybridization. So alpha carbon must be sp3 hybridized. So that compounds are participate in aldol condensation. So next, okay, so the next, in aldol condensation, which is the reagent? So aldol condensation reagent. So reagent is dilute sodium hydroxide. Okay, dilute sodium hydroxide. Okay, dilute sodium hydroxide. So next to second one, heat or concentration H2SO4. Okay, concentration H2SO4. Concentration H2SO4. Okay, so then these are the reagents. But what is the substrate? Substrate is the alpha hydrogen containing carbonyl compounds. Okay, alpha hydrogen containing carbonyl compounds. Alpha hydrogen containing carbonyl compounds. Okay, carbonyl compounds. So these are the substrate. Okay, this is a reagent. So suppose I can take one example, acetaldehyde. So acetaldehyde. So this is the participant in aldol condensation. Okay, this is a participant in aldol condensation. So because of alpha hydrogens is there, that's why this is a participant in aldol condensation. So I can write here 2 moles of acetaldehyde. So here, so with alpha hydrogen carbonyl compounds. So here reagent is sodium hydroxide. This is a dilute. Okay, second one is heat or concentration H2SO4. So in this reaction, dilute NaOH act as a base and heat and concentration H2SO4 act as dehydrating agents. So dehydrating agent means so the species which can remove of the water molecule from the substrate. Okay, from the substrate. So here we get a product CH3. Just a minute. So first I can use dilute NaOH. So we get CH3, CHOH, next to C double bond OH. So this is the functional group. So just a minute. No, एक minute. Okay, CH2 and C double bond OH. Okay, OH, sorry, C double bond OH. So this is the functional group. Adjacent carbon is alpha carbon, then this is the beta carbon. Okay, beta carbon. So here beta hydroxy carbonyl. Okay, beta hydroxy carbonyl compounds are aldol products. Okay, so aldol products. Aldol products. Aldol products. Okay, aldol products. So aldol products. So then I can use concentration H2SO4 or heat. Okay, concentration H2SO4 or heat. Concentration H2SO4 or heat. So I can write here. So CH, H. So here electron displacement was. So we get beta hydroxy unsaturated carbonyl compounds. Alpha beta unsaturated carbonyl compound. This is a functional group. So adjacent carbon is alpha, then beta. So alpha beta unsaturated carbonyl compounds. So here H plus and OH eliminated as water molecules. Okay, this is a general reaction of the aldol condensation. So now I am discuss about the mechanism. Okay, mechanism. Okay, mechanism. So here the reagent, first one is dilute NaOH. Okay, dilute NaOH. So dilute NaOH means sodium hydroxide dissolved in water molecule. Okay, water molecule. So sodium hydroxide is a strong electrolytes. So that's why it is the complete dissociated into their respective ions. sodium plus and OH minus. Okay, OH minus. So this is the first one. So second step. So here substrate is alpha hydrogen containing carbonyl compounds. Okay, compound. So I can write another way, CH2 and H. So here I can use the base. What is the function of the base? What is the function of base? Base which can accept the proton from where? Acidic center. So this is a minus M group, because of this is our system connected to carbon again connected to more electronegative element through pi bond. So that's why this is act as a minus M group. So electron displacement towards here, okay, this proton capture this hydroxy group, eliminated as water molecule. Okay, water molecule. So in first mole to forms carbene ion. Okay, carbene ion. So this carbon gets negative charge. So it is act as a nucleophile. So because of it is nucleophile. So because of electron rich species. So then third step. So I can use 1 mole of aldehyde. So I can use second mole of aldehydes. Second mole of aldehyde. The second mole of aldehyde. So here this is act as a nucleophile. So nucleophile attack on electrophilic centers. So generally carbonyl compounds are participating in aldol condensation. Generally aldehydes, carbonyl compounds are participating in nucleophilic addition. So here oxygen more electronegative, partial positive, oxygen partial negative, carbon partial positive. So that's why this nucleophile attack on electrophilic centers. Okay, electrophilic center. So here nucleophile attack on here, electron displacement towards here. So we get CH3. So next to second carbon, this carbon has one hydrogen. So next to O minus, this carbon connected to CH2. Okay, CH2. Okay, CH2, C double bond OH. So this reaction and dilute NaOH. So dilute NaOH, this reaction depends of dilute NaOH. So here OH eliminated along with hydrogen, eliminated as water molecule. So that's why here this water molecule, so here this is the base act as the catalyst. So that's why OH minus is eliminated as catalyst. This proton, so attack on this negative. So we get CH3, okay, CHOH, then CH2, then C double bond OH. So this is the aldol product. Okay, this is the aldol product. So this is the functional group. Adjacent carbon is alpha, then beta. So beta hydroxy carbonyl compound is called aldol product. Aldol product. Okay, aldol product. So then now I am using the concentration H2SO4 or heat. Concentration H2SO4 or heat. Okay. So concentration H2SO4 act as a dehydrating agent. Okay, dehydrating agent. So here, so I can write this is the CH2H. Okay, I can write CH2CH. So here, this is also I can write CH H CH H. Okay, so here this electron displacement towards here, this is the A possibility. Okay, OH minus is leaved. So again this electron displacement towards here, this is the B possibility. Okay, B possibility, OH minus is leaved. So first A possibility, so I can write A possibility. So A possibility, CH2 double bond CH, then CH2 C double bond OH. So then B possibility, if you have these electron displacement here, double bond formed in this carbon, between these carbons, so we get this is a single bond. Okay, so here B possibility, so CH3, my H and CH2 CH3 CH, so double bond formed between these two carbon atoms, CH C double bond OH. So here two products are possible, A and B. Which is the major, which is the minor? So here this is alkenes. Okay, this is the alkene, this is the alkene. Stability of alkenes explain the hyperconjugation. So this is our system, alpha carbon. How many number of alpha hydrogens is there? Only 2 alpha hydrogens. Alpha hydrogens जो जैसे 2 alpha hydrogens. So here this is the system. How many number of alpha hydrogens? 3 alpha hydrogens. Okay, alpha hydrogens 3. So this is the system. Here alkene is the system. Here also alkane is the system. System adjacent carbon is alpha. So this is the system. System adjacent carbon alpha. Alpha must be sp3 hybrid. So here 3 alpha hydrogen is there. So that's why this is the major product. Okay, this is a major product. So functional group adjacent carbon ఏమంటారంటే alpha and beta carbon. Okay, alpha beta unsaturated carbonyl compounds are formed in that reaction. So this is the mechanism. Okay, so now shortcut journey. How to shortcut? Okay, so suppose CH in this reaction 2 moles of acetaldehyde is used. So this is the 1 mole. So I can write second mole uses. Second mole C double bond OH. So if I remove this H2O molecule, so we get a CH3, next to CH. So here double bond formed between this carbon and this carbon because of water molecule is eliminated. CH and C double bond OH. Okay, this is the functional group adjacent carbon alpha, then beta. Okay, so beta hydroxy carbonyl compound. So this is the shortcut, dilute NaOH. Okay, so next concentration H2SO4. So this is the shortcut mechanism. Okay, so next so my question is, so for example CH3 C double bond OH. So this is a aldehyde, so which contains alpha hydrogen. So this is participating in aldol condensation. So I can take one more aldehyde, different aldehyde. So different aldehydes. Okay, different aldehyde. So I can take different aldehyde, CH2 and C double bond OH. So concentration, dilute NaOH, and second one concentration H2 SO4. Okay, concentration H2SO4. So how many products are obtained? So JEE, how many number of products are obtained? So I can write this is a R. So this is the R prime. So this is a one halide. So the possible products are, okay, possible products, how many possible products entered? So generally, so 2 products, second one 3 products, so next to third 4 products, so next to fourth one 1 product. So generally in these reactions, so 4 products are obtained. So first one is RR. So 2 moles of acetaldehyde react with RR product. Second one is 2 moles of R prime. Okay, then third one వచ్చేసి R prime and R. So next to fourth one వచ్చేసి R and R prime. So 4 products are obtained in that reactions. So in that reactions. So which products are obtained in that reactions? So 4 products are obtained. So now I can both moles of both same moles. First one just I can write R this one. Okay, so CH3 CH2 C double bond O H. So I can use shortcut trick. CH3 C double bond H. So water molecule is eliminated. So we get first product. So first product CH3 C H double bond between these 2 carbons, CH just a minute. This is the CH. Okay, this is the CH. Okay, CH C double bond O H. So this is this compound name is, so 1 2 3 4. Okay, so but root word is but. So second position 2 in. So next 1 all. But 2 in 1 all. This is the first product. So I can write the second combination R prime and R primers. So second combination R prime and R prime. Okay, R prime. So R prime is a propanaldehyde. So I can write CH3 CH H C double bond O H. So next to CH3 CH2. So another propanaldehyde H. So water molecule is eliminated. So we get CH3 CH2 and CH. So second product. So I can write second product CH3. So next to CH2 CH double bond C. So this carbon connected to 1 methyl. So next to C double bond O H. So this compound name is, so here this is a 1, so 2, 3, 4, 5. Okay, root word is the pent. Okay, so root word is pent. So double bond present at second position, 2 in. Okay, 2 in. So next first position, all. So 1 all. So this is a pent to 2 in, 1 all. These two are self products. These two are self products. That means RR combination gives first product, R prime R5 combination gives second products. So now I can take another possibility product. Okay, another possibility product. So first one is R and second one is R prime, crossed product. So first one R, second one, okay, first one R, second one R prime. So that means these are the crossed product. This is a 1 mole of acetylate, second mole of a propanaldehyde. So I can write CH, H, H, C, double bond O, H. So then CH3 propanaldehyde, CH2 and CH, okay, CH. So just a minute. C double bond O, H. This is a propanaldehyde. So here water molecule, shortcut trick. So water molecule is removed. So we get CH3, next to CH2, so next to CH. So here double bond between this carbon and this carbon. So CH and C double bond O, H. Okay. So this compound name is, so this is the first one, second carbon, third carbon, fourth carbon, fifth carbon. Okay. So root word is pent. Okay, root word is pent. So here, this is a mistake. So here CH3 is there. So second position on the prefix, ante 2-methyl. First the name is 2-methyl. 2-methyl pent 2 in. So here 1, 2, 3, 4, 5. So 4, 5. So root word vachesi pent. So next second position double bond, that means 2 in, pent to 2 in, 1 suffix in the aldehyde all, 1 all, pent to 2 in, 1 all. So this is the third product. So first one, second one, third one. So this is the crossed product. So because of one is the acetaldehyde, another one is propanaldehyde. So I can write first. So first I can write R prime. So then R, CH3 and CH2, CH2, I can write CH2 like this, H, H, C double bond O, H. So I can write second one, acetaldehyde, CH3, C double bond O, H. So I'm using the short trick, eliminated as water molecule. So we get so 1, 2, 3. So fourth product, CH3, CH3, CH, C. So here CH3, C, double bond O, H. So here this compound name is, this is a 1, 2, 3, 4. So root word is 4, root word is 4. So the bute so bute 2 in 1 all. So here second position prefix is there. So 2-methyl bute 2 in 1 all. So this is the fourth product. Okay, this is the fourth product. Okay, so how many products are possible? The 4 products are possible. So then, so one more question. Dilute NaOH and the concentration H2SO4. So we get which of the following product is obtained? So first one, this is the option, first option. So second option, okay, second option. So next, third option, okay, third option. Then fourth option. Then fourth option. So which is the correct one? Okay, which is the correct one? So here this is a cyclohexanone. So dilute NaOH and concentration H2SO4. This is the 4 options is there. So here which is the correct option? Okay, which one is the correct option? So we know that short trick. Okay. So here this is the ketone. So I can use another mole of ketone. So here 2 hydrogens is there, alpha hydrogens. So here also 2 alpha hydrogens. So we get, so this is another mole of H2. So we can write H2O is there, remove. So we get double bond O. So this is the product as major product. So which one is the answer? So fourth one is correct answer. Okay, fourth one is correct answer. So I can write one more example. CH3 C double bond O H plus H C double bond H. Okay. So dilute NaOH and concentration H2SO4. Okay, concentration H2SO4. So which product is obtained? Okay, so here first step, this is a first one with alpha hydrogen containing carbonyl compound. Second one is without alpha hydrogen carbonyl compounds. Okay, so CH3 C double bond O H. So I can write another way. Okay, CH2 H. So generally base OH minus which can accept the proton. So which can accept the proton from alpha hydrogen. So electron displacement toward this carbon, hydrogen react with OH minus eliminated as water molecule. Okay, then so we get CH2 C double bond O H minus. This is the nucleophile. Okay, nucleophile. So in second step, nucleophilic attack. So I can use another mole of carbonyl compounds C H. So this is the nucleophile. So nucleophile CH2 minus C double bond O H. So this is the nucleophile. So generally carbonyl compounds are participate in nucleophilic addition reactions. So here oxygen is more electronegative, partial negative, carbon partial positive. This negative attack on here, electron displacement towards the oxygen. So why electron displacement towards the oxygen? Oxygen is the more electronegative element. So that's why electron displacement towards the oxygen. So we get H. So first carbon contain 2 hydrogens and O minus. This carbon connected to CH2 and C double bond O H. So O minus is there. So here I can use the first OH minus. So this water molecule I can use here. So OH minus is eliminated as base and this H plus ion attack on here. So we get this carbon has 2 hydrogens. So then connected to oxygen, oxygen attack to proton OH, this carbon connected to CH2, then C double bond OH. So this is a beta hydroxy carbonyl compound. Okay, so this is the alpha carbon functional group addition. This is the beta hydroxy carbonyl compounds. So beta hydroxy carbonyl compounds I can use it. Concentration H2SO4. What is the function of concentration H2SO4? Concentration H2SO4 acts as a strong dehydrating agent. So strong dehydrating agent. So I can write this carbon another way. CH and H. So here electron displacement to here OH minus is leaved. H plus and OH minus eliminated as water molecule. So we get double bond formed between these 2 carbon atoms. That's why CH2 double bond CH, then C double bond H. So this is a functional group adjacent alpha and a beta. So alpha beta unsaturated carbonyl compounds. So this is the Aldol condensation. So one more example. So next, so I can take one more example, internal Aldol condensation. So what is the internal Aldol condensation? So before the discussion about the internal Aldol condensation, so we know knowledge about the internal Aldol condensation. Internal Aldol condensation. So internal Aldol condensation. Okay. So here in single compound base which can accept the proton and nucleophilic addition takes place in the same compound. So that's why this reaction is called internal Aldol condensation. So for example, before the discussion about the internal Aldol condensation, so this is the 3-membered ring, so 4-membered ring and 5-membered ring and 6-membered ring. Okay, so 7-membered ring. Okay, so which is the most stable rings? So 5-membered and 6-membered rings are more stable because of less angle strain. So more angle strain, these are unstable. 7-membered and 3 and 4-membered rings are unstable. 4-membered and 5-membered rings are stable. Dilute NaOH, and concentration H2SO4. So the product, which product is obtained? So here base. So this is a participate Aldol condensation or not? First of all, this is participate in Aldol condensation, because of this is the alpha carbon, this is also alpha carbon must be sp3 hybridized. Okay, this is also alpha carbon, this is also alpha carbon. So here this is this alpha carbon is same, so I can write alpha prime, this is same, this is also same. So in case base which can accept the proton from where? So two possibilities is there. So in case base here, so base which can accept the proton from this alpha carbon, so 1 2 3 4 5 6 membered ring is possible. Okay, so in case base which can accept the proton from this alpha carbon, okay, so this nucleophile attack on 1 2 3 4. So nucleophile attack on 1, so this is a nucleophile. Whenever the base attract the proton from this carbon, this act as a nucleophile. This nucleophile attack on this carbon, so 1 2 3 4 membered ring. So 4 membered ring is unstable. So that's why base which can accept the proton, so proton accept from here. So this is also same, this is also same, accept to here. So got electron displacement towards this carbon. So this H plus ion react with OH minus, eliminated as water molecule. So we get, so this is the minus. So suppose I can write numbering. So 1 2 3 4 5 6 7. So here this nucleophile attack on here, electron displacement towards oxygen, electron displacement towards oxygen. So how many number of rings formed? 6 membered. 1 2 3 4 5 6. So we get 6 membered ring. So first we get 6 membered ring. So 1 2 3 4 5 6. So here second carbon has ketone and a double bond O. So next to sixth carbon in the O minus, then sixth carbon connected to seventh carbon. So I can write this right. So 6 membered ring is formed. So 1 2 3 4 5 6. So then here first carbon connected to sixth carbon, electron displacement towards oxygen, and the sixth carbon has O minus. Okay, then sixth carbon connected to methyl group. Okay, CH3. So then first carbon adjacent carbon has double bond O. Okay, double bond O. So then, so I can use, this is the water molecule is eliminated. So here the water molecule OH minus is eliminated. This H plus ion attack on here. So we get C double bond O. Next O minus Sir, O minus converts to OH. OH. Here methyl group is there. So then dehydration takes place. Concentration H2SO4 act as dehydrating agent. Okay, concentration H2SO4 concentration H2SO4 dehydrating agent. So here hydrogen is there, this electron displacement towards here, water molecule is eliminated, H2O. So we get product is double bond O. So here unsaturation is there, CH3. Okay, this is the alpha. This is alpha functional group, alpha carbon and beta. So beta unsaturated carbonyl compounds. So this is the internal aldol condensation. Okay, thank you everyone.